Hello, 7th grade. Welcome to Chapter 1, Lesson 4. As you can see, our learning target today is to find opposites and absolute values. So a little bit different than the expressions that we have done for the past couple days so far. There are going to be some things in our notes that we need to write next. So if you don't have your notes out, please pause and find them. The first thing for our notes, when it says the goal is to find opposites and absolute values, we probably should figure out what those things are. So first we need to know what opposites are. Opposites are numbers that are the same distance from 0 on a number line, but in opposite directions. Feel free to draw yourself a little picture also. So you can see in this number line that 4 and -4 are opposites of each other because 4 is 4 spots or jumps, whatever you'd like to call them, to the right, while -4 is 4 spots to the left. This would work with any number. If I start at 0 and go right twice and left twice, we now see that -2 and 2 are opposites. I could go right 100 and left 100. 100 and -100 are opposites of each other. Please write that down in your notes section. This is a good question on how you would see this maybe on your MCA test in May. It's asking which point is located at the opposite of -2. And do you know what a common 7th grade mistake is? I saw -2 and I saw K and I just wanted to be done with this test, so I clicked it as fast as I could, but oh no. It said the opposite of -2. Well, if -2 is left 2, the opposite would be right 2, and my actual answer, M. Again, if you need more time, feel free to press pause before you start our second word of the day. Second word of the day, integers. This is exactly where 6th grade left off. Integers, whole numbers and their opposites. Whole numbers, no decimal, no fraction. Whole numbers, 1, 2, 3, 20, 27, 52. Their opposites, -1, -2, -3, -27, -52. All of those are integers. Pause when you need to write in your notes. Integers show up in a lot of real-world places that you maybe don't realize. For example, if you have the type of thermometer at your house, or I actually have one in my refrigerator because sometimes it gets too cold and my milk starts freezing, that shows you the red dye for the temperature. Well, this one is like a number line on its side. Here's 0. So the temperature now would be below 0, a whole number. 1, 2, 3, 4. It's at a whole number below 0. -4 degrees Celsius. That would be freezing. My milk would for sure be ice. Other places that you see integers. If you log into a bank account, or you are paying someone with Venmo or a Cash App, whatever it is that you would use to pay money for someone. If I lose $7, I will see in red, I have lost it, or maybe I paid someone back when I went to the movies with them. I would see a -7. That is an integer. Find 9. My lucky day, I found $9 in this sweatshirt I haven't worn for a while. That would be a +9. And now a lot of times positive numbers, you don't actually see the positive. We've stopped writing the positive there to save ourselves an extra second or 2 or 5. You don't usually see your grandma sending you a happy +13 birthday. It's just 13. We know that when there's just a 13, it's going to be positive. But on my Venmo app, it does say a plus next to it, meaning I got some money. 8 steps forward. That would be a positive gain, like in football. Same thing for 3 yards gained. And then 5 floors down. That would be a drop or a -5 down. So integers show up a lot of times in our real life situations. You can also see integers on a graph. You would order and compare them from least to greatest. So I'm just going to start by putting a dot on my -1, my 4, and my -5. Some people like to put the dot up above so they can still see the numbers. Other people like to put it right on the number line. Both are okay. And then it says compare these numbers least to greatest. Here's how I remember it. Least left. Least left. So which one is on the left? A -5. I know what would happen if my 3-year-old saw something like this. He'd get out a car and he would start driving along. And if least is left, the further you go to the right, it must get bigger. So the next number would be -1. He continues his car driving to 4. This next part might be a little bit of a change for you as we're getting ready for our algebra class. You use 2 less than signs if you're putting your numbers in order from least to greatest. 2 less than signs. -5 is less than -1, and -1 is less than 4. Pause if you need more time for your notes. Third word of the day, absolute value. Absolute value is a type of grouping symbol like parentheses. So when you see these absolute value marks, that's a signal to your brain, hey, I got to do that first. I got to figure this out. What it means is how far a number is from 0 on a number line. And you know when absolute value is happening because these two longer lines, or some people call them bars, are around the number. So you'd read that out loud as the absolute value of 3. How far away is 3 from 0 on a number line? Definitely pause to write stuff down. Here's where we might see some absolute value in our problems today. So remember, absolute value are a grouping symbol like parentheses. I have to do that first. First, 9 plus 4, 13. How far away is 13 from 0? Oh, that's 13 jumps. So this whole thing just becomes a regular 13. 14 minus 13, 1. So that whole long numerical expression just simplified down to a 1. Absolute value, like parentheses, you must do that first. How many jumps is -4 from 0 on a number line? 1, 2, 3, 4. So this simplifies down to 4. Be careful that you're not doing 54. The hidden multiplication was in there. Final answer, 20. This third one looks a little scary. Why are the subtraction and the negative right next to each other? But I'm only looking at the absolute value first. How far away is -10 from 0 on a number line? 10 spots. Bring down the subtraction and the 15. 15 minus 10, 5. A couple other tricky things. How far away is -7 from 0? Just 7 spots. How far away is +10 from 0? 10. But that's weird. There's still a negative on the outside. That means the negative gets attached. So just when people are saying to themselves, oh, I got it, right? The answer is positive every time. No big deal. Turns out that's not actually true. The last one might be tricky for some people who haven't practiced negatives a lot. If you have $5 and you try to spend $7, the cashier at Culver's is going to say, sorry, you don't have enough money. You're going negative. But there's still those absolute value bars that we need. What do those absolute value bars mean? How far away is -2 from 0? 2 spots. +2. That whole expression simplified down to 4. There is a worksheet with many, many examples of absolute value on it. Just like I was doing on these last 6 examples. Look at the absolute value part first, solve that part first, write down the answer to the absolute value part first. Then solve whatever is left. Do you have subtracting to do? Do you have multiplying to do? Do you have adding to do? After you take care of the absolute value. You should have a worksheet for this. Please don't just go as fast as you can. That doesn't seem like a good way to learn. I hope you have a wonderful day. Bye.